We'll go ahead and get started. Hello everybody. My name is Eric. Today I am joined by some of my AI students over at the University of Denver. In a moment, I will let them introduce themselves as well as have the floor for presenting one of their projects that they have done for this course. A tiny bit of background about myself in this course. I've been instructing these AI, data science, and machine learning courses for going on more than 5 years now. I'm a practitioner in the field with over 5 years of experience in data and AI and over 12 years experience in education. About this AI course in particular, it ranges from intro to Python all the way to what we're learning now, which is the intricacies of large language models, neural networks, their applications, and building real world application projects around it. This project in particular marks their more than halfway point for the students, where they have already learned at this point computer vision, recurrent neural networks, XGBoost, Boltzmann machines for recommendation engines, just to name a few, as well as the pre-processing and the wrangling techniques, such as normalization, standardization, all these things to handle data leakage, imputation for missing data, etc. They have gone through the gamut. Overall, lots of great learnings have happened in this course, and I'm excited for the opportunity for this group's project in particular to showcase their work. Again, while I don't want to steal too much thunder, these do represent this sort of top of my class in terms of student projects. They've graciously accepted an invitation to present to a greater audience. They themselves have a varied background of incredible skills that are now augmented by this skills in artificial intelligence. What they put together today was a real world was a solution to a real world problem. As a reminder, it's never about whether or not this has already been done, rather, it's the value of the work. I emphasize the latter to the students because it's not always the complex solutions that also shine. If anything, the simplest ideas used correctly have just as much, if not greater, impact. And this project showcases this ability to see value where it might lie in this space, both for a consumer, as we will see, and for them as they have done the analysis into the market for their own skills. All of this content will be exposed on a public GitHub. I believe they also have a demo with a public link, which is really cool to see. The students will curate this, and you all are welcome to examine and visit this content as well as a live link to the application that will be provided. I don't remember if it's a QR code or if it's a link, but we'll get to that point in a moment. A proud note on my part, I didn't teach this group Streamlit, so I only mentioned it like a few days before they had to turn this in, and they took it and ran with it and made a POC, creating an MVP in a very short amount of time, which I think speaks to their efforts and speaks to their abilities. But without further ado, I'll just talk about the format very quickly. These students will have about 15 minutes or so to present. Mind you, they were only given 10 minutes in class. And in this, just to effectively teach them delivery skills under pressure. This may or may not be followed by some Q&A on my point, but on my part. But at that point, I will provide a simple thank you, and we'll close the presentation recording. So, without further ado, I will hand it off to Michael, Nick, and Zane to present themselves and also present their projects. Guys.
Hi, I'm Zane Master. Thank you, Eric, very much for that wonderful introduction. I'm Zane Master. I'm a product management side of the house person. So I bring that skill set along with all of the things that are being augmented by Eric and under his tutelage to make me more AI oriented as well. Michael?
Hi, I'm Michael. I serve as a data scientist, data analyst on this project. And my work in this class is focused a bit more on retail and e-commerce data science. And you'll see my work for this project here in a moment. Nick?
Yeah, hi. I'm Nick Silas. I was the data engineer and software engineer on this project, and I just love getting down and dirty with the code. So you'll see it here. Okay.
All right. Without further ado, I'm going to kick off the presentation. So Welcome. We're Team Automators, and we'll be pitching to you the MaxiMile Intelligent Ride Solution System that we've developed for drivers and riders. Short outline of what we're going to cover today in our pitch deck. Again, a brief introduction of the team, talk to you about an actual problem we're solutioning for, what approach we took to solve this problem, showcasing our prototype, and then finally going out with next steps on where we can take this project and move forward with. So this is our team. Michael, who was our lead scientist, Nick, our lead software engineer extraordinaire, yours truly, the ideas engineer, and an honorary mention, Lawrence, a real Uber Lyft driver who actually helped us understand the problem he faces as a driver. We focused on problems in the for-hire vehicle market for both riders and drivers. So let's learn a little bit about these problems. Driver issues. Drivers such as Lawrence that we just met a little bit earlier, or our honorary member, who drives for both Lyft and Uber, faces uncertainty in earnings. A lot of deadheading, which is driving aimlessly around to pick up rides between rides, and driver saturation in markets where there's higher driver density. While we think cab, Lyft, Uber drivers take a lot of the fare home, they technically don't. Expenses, part of the revenue share model, fuel, insurance, and other costs eat into those earnings. On the flip side, riders, like our persona Haley here, also face some level of uncertainty in pricing the ride time and find themselves switching between multiple apps to find the best service for the trip that they've planned. So knowing both sides of this market-faced problem, we knew we had a real problem to solve. With our solution for riders, we can cost compare rides and transit times to destinations, versus for drivers, we want to maximize the earning for drivers like Lawrence and show them routes with the highest earning potentials. So let's talk about what we needed to get those solutions. We built a proof of concept using New York City transit data, a place with really high driver density and rider density. We used a lot of this good data that was available to us and included live APIs into the project. All this data was ingested via Parquet, and the model was trained on a common shared data set. That helped us quickly create unique data frames for our unique models that went into the larger project. Now, just an interesting snippet about the data while we were analyzing that we found. After plotting it, we found some of our initial hypotheses to be wrong, which is why it's always good to plot data. For example, yellow cab fares and ride times were significantly higher cost than Uber or Lyft. And on an interesting note, that blank spot that you see in the Uber Lyft data, it actually threw our models off initially because there was a mismatch between the target and feature set. This actually was due to a lockout issue that surprisingly drivers where they were locked out of their applications, as shown in the image earlier, where they were protesting against the low pay wages, and then the Uber and Lyft companies actually locked them out during that period of time. So interesting to just see how that affected the data and what we had to do to massage it. So what did we build? For our writers of the problem, we built, well, an ensemble model that was trained on that New York City transit data that compares predicted total price between the three services, predicted duration of the ride. And our models were accurate enough to predict within $4 and 4-minute variance of the truth. But enough of me talking, let's see the prototype for the Rider app. Nick?
All right. Thank you, Zane. Me share real quick. All right. So like he had said, we trained and tuned a price prediction model and a duration prediction model to compare the cost and ride times between Yellow Cab, Uber, and Lyft within New York City. Now, while testing the predictions of these models with various pickup and drop-off locations, as well as different traffic factors such as weather and time of day, it was somewhat cumbersome to use. So I wanted to streamline this process for better visibility and usability, and this became the foundation of our app. So using Streamlit, I was able to spin up an interface fairly easily within Python. And as you can see here, it's even hosted on Streamlit, so you can go to this URL and play around with it if you'd like. But anyways, how does it work? By using a leaflet map library, I fed it the New York City coordinates and was able to bring in all 263 unique pickup and drop off region locations along their latitude and longitude coordinates to populate this map with accurate interactable location markers. So what this means is if we click on one of these, it will fill in our pickup location parameter. And if we click on another one, it will set our drop-off location parameter. Now, when we hit run prediction here, it's going to pull in the current date and time of New York City, unless specified otherwise, from the sidebar here. It's also going to ping the closest weather station to further populate traffic factors for the models with precipitation and current temperature. So when we hit run prediction, we see at a glance that for a trip from Newark Airport to Bloomfield, that Uber is the cheapest option currently, and Yellow Cab seems to be the quickest, but it's also the most expensive. Now below we have some more detailed trip information such as distance, current temperature, precipitation, and timer request. Now this is great and all if you actually have the time or the hands to interact with the map or the drop-down boxes, but what if you didn't? So using OpenAI's API, I brought in a GPT 3.5 turbo model and trained it to identify pickup and drop off location keywords from a user's naturally spoken or written language input. So for instance, you can type a request into the box here, or you can click the microphone and say something like pick up Mariners Harbor, drop off Newark Airport. Speech to text will then translate and populate the input box with what you said. And then the bot or LLM will hopefully identify your desired pickup and drop off parameters to feed into the prediction models. So when we hit run prediction here, we should see the result for our desired trip without ever having to fiddle with the map or the drop down boxes, adding a more hands-free and intelligent option for busy New Yorkers, which I think is really the main goal here, right? So with this being a prototype, there's much to expand upon. For instance, this app version is simply for the benefit of the rider, whereas Michael's been working on how we could adapt this for the benefit of the drivers as well. So I'll let him take it from here.
Okay.
Thanks,
Thank you,
Nick.
Nick.
As they mentioned earlier, our target is the rideshare driver, as well as automated solutions like Waymo and soon-to-be competitors like Tesla. Um, Here you can see a map of the 5 boroughs, as well as a heat map of basic average earnings per hour for specific pickup locations. This, however, is a static view of what is actually a dynamic problem. To handle this dynamic and changing problem, we've designed a decision support system. With this system, drivers no longer need to guess or engage in this deadheading behavior Zane mentioned. Using 2 models, our system can predict the average earnings for a given location and subtract the opportunity cost as transit duration and find the most advantageous next pickup location. Here on this slide, you'll see some technical details. In working on the decision support system, we've sharpened the duration model to a mean absolute error of 3 minutes, down from the 4 minutes Zane mentioned earlier. More importantly, we've built a weak but useful model to predict next pickup location. This model performs well above any naive baseline we've tested. Critically, it performs above any guesswork that drivers perform on their own, making it the best solution to this previously unaddressed problem.
So let's talk about next steps. Michael, thank you for that deep dive. So we strongly believe that our idea offers a unique solution from what we have available in the market right now. For the rider, there isn't anything that compares cost or ride times unless you have them switching through the multiple apps trying to input their drive, duration, times, duration locations, and pickup locations. For the driver, nothing best of our research abilities exists in the for-hire vehicle or the robotaxi market at this point in time. And furthermore, our research shows that this would be a great solution for those robotaxi companies looking to optimize their earnings, especially after the heavy upfront investment. So it's frozen. I don't know what's going on.
No worries. Technical difficulties. We see that robotaxi
All
market
right, there we go.
size. Perfect.
While we believe it's a good idea, we wanted to find out if the idea could hit the ground running. So we did a quick analysis of the market opportunity here, taking into account the TAM, the SAM, the SOM, or the total addressable market, the serviceable addressable market, and the serviceable obtainable market, and possible revenue models that would work, churn rates, calculations. But here's the key takeaways. While the number of assumptions are baked into the quick calculation of the market opportunity here, the key takeaways are it is a sizable market with a real opportunity, US first, of course, international thereafter. A subscription model here makes the most sense that wouldn't break the bank. We tested this number against some of the drivers like Lawrence and others we, interim took rides with to understand if this would work for them. And then lastly, a solid ROI and a break even within the first year based on our calculations, that's definitely something to write home about. So, what are we thinking about doing next? We strongly believe that there's a real market opportunity here and would like to continue building and refining the models, especially the ones that Michael discussed for the driver. One of the first things we have planned is to build the ability to stream in real time data to update drivers and passengers in real time, file a provisional application specific patent to then protect our IP. And that will actually help us kick off conversations with for-hire vehicle companies and robo-taxi companies as well. Later in the year, as we get to, much more heavy ride times, given the holidays, we plan to launch our rider-specific app in specific markets that we can then grow and learn from as the launch takes place. And then in October, a big marketing push before the travel heavy season so we can get riders and drivers onto our platform. So thank you for your time, and we're really excited to bring this idea to life.
Awesome. Fantastic and incredible presentation once again. Just reminding the audience that the uh, the application QR code I assume is provided. That is there on the screen. It'll also be again provided in the GitHub repo, and it's in the presentation itself if you want to take a look at it again. But thank you all again for this presentation. This was a great showcase of technical depth, creativity, and real world application from that Streamlit POC, which was spun up very, very quickly and used, I think, to perfection here to showcase, what this could eventually look like at scale is amazing. Large language model integration, which is obviously all the rage now. And you guys worked with it flawlessly. And you didn't even learn that by that time in this course. It was just a real quick, hey, this is how we do things, and a couple of sessions on how to do that, and you ran with it, which is great. Um, can't wait for project 3 on that one, where we dive even deeper on how to use these things, even to the analytics and the ensemble modeling. That's I think this was all showing great again fundamentals, depth, real world application, all reflecting the core of what's sort of been learned in this course. So I'm very grateful, and special thanks again to Nick, to Zane, to Michael for sharing their projects with us. Again, reminder, presentation recording will be available on YouTube. All the related materials, the code, the links are all going to be shared on GitHub shortly hereafter. But I appreciate your time and thank everybody for tuning in. Thank you.
Thank you.
Thank you.